Alright, this video is about the activity series. The activity series is in your reference packet, and it has metals which are listed in order from most reactive, which are the easiest to oxidize, to least reactive. The more reactive metal can replace the least reactive metal when it's combined in a compound. So we'll use it to help us determine. We've already talked a little bit about reactivity when we talked about periodic trends. So we talked about how we talked about how the metals were reactive, and when we looked at those videos, if you remember that. So anyway, we're going to be looking at that some more. So if we'll turn to page 7 in your reference packets, again, page 7 on your reference packet, same page, your polyatomic ions, and you will be able to see your activity series. Alright, so for this first one, we have lithium and copper that we're looking at. Okay, so again, the more reactive metal can replace the least reactive metal when it's combined in a compound. Okay, so lithium, in other words, we want to know, can lithium replace copper? Will this reaction occur? Lithium can only replace copper if lithium is above copper in the reactivity series. So if lithium, that's all by itself, if it's more reactive. So lithium is up here at the very top. It's very, very reactive. Okay, so lithium is above copper. So yes, this reaction will occur. And so we can then write it. So lithium will kick copper out and combine with nitrate. So we'd write that together. So since lithium's a +1, nitrate's a -1, we get lithium nitrate, and then we would kick copper out by itself. Since everything is plus and -1, it all gets balanced out. But if we look at it the opposite way, copper, you see, is way down here at the bottom. Okay? Copper cannot replace lithium because lithium is more reactive. Okay? So this would not happen. So this would be no reaction. Okay? So the element that's alone has to be above the element that's combined. Okay, let me write that out here. The element that is alone must be above the element that is combined. Okay? So let's look at this. If we put sodium into a solution of silver, okay? So sodium is sodium above silver. Yes. So that reaction would work. So we have sodium plus silver, right? So that means this sodium will become an ion and the silver will get replaced. Right? I mean, the silver would come out of the solution. Would the opposite happen? Can silver replace? No, it cannot. So this would not occur. So this would be no reaction. Okay? This, if this is confusing too, would be the same as if we said sodium plus silver chloride. Okay? So we would get sodium chloride plus silver. Okay, but we know that this is like the net equation. Whoops, sorry. This is like the net ionic equation, right? Because the chlorides would cancel out because it all dissolves in water. Alright, so you try the next two. Pause the video and you try. Alright, so let's look and see. Is aluminum above barium? Aluminum is not above barium, so this should be no reaction. Okay. And then letter B is lead above magnesium. Lead above magnesium. Nope. And so this one would be no reaction. You can also abbreviate. No reaction. Okay. But if we were to flip this around, we'll just do one, flip it around. If we were to flip that around to magnesium plus lead, right? We flipped it around like that. Would that one work? Yes, it would, because magnesium is above lead. And so we would get magnesium chloride and we would kick lead out. Right? Let's look at one more. It's like we need to see one more where we have to write it on our own. No, that one. You try that one. Zinc plus copper 1 nitrate. And zinc above copper. Yes, zinc is above copper. So since zinc is above copper, it will replace. So zinc will combine with the nitrate, but remember, zinc has a +2 charge, right? And so for this one, we would have to balance out with some 2's, right? Now if you also look, we have the activity series of halogens just above that. This also works for halogens. So if, let's say we had chlorine reacting with, well, I don't know, let's say hydrobromic acid, let's say. Can the chlorine replace the bromine? Same thing works. Is the the element by itself, is it more reactive than the combined element? Is chlorine higher than bromine? Yes, it is. So then you'd get HCl, and bromine would be on its own. And since bromine's diatomic, you'd have a 2, right? And so then you'd have to balance that out. Okay? So that same thing works for the activity series of halogens above. Alright? And there we go. And that's our activity series.